This is Dr. Shirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about sorting techniques and one of the most prominent sorting technique, which is merge sort. Let's have a look at that one. Merge sort. Before that, let's see what sorting is and what type of sorting techniques we have or we learn in the academic point of view. Sorting technique is nothing but arranging the data in ascending or descending order. There are various types of sorting techniques like bubble sort, insertion sort, selection sort, quick sort, merge sort, heap sort, and many more. So these are the most prominent one. Out of all these, today we are going to learn about merge sort. What is merge sort? It relies on divide and conquer technology. What is divide and conquer then? Divide and conquer means splitting the data into halves and sorting the left hand side as well as the right hand side and merge them. Right? So dividing the things and winning the battle is nothing but divide and conquer technique. Right? So and merge sort is going to adopt the same. It divides the list into halves. Right? Coming to the complexity of merge sort, the best, average and worst case is n log n, big O of n log n, which is quite less when compared to the earlier sorting techniques like insertion and selection. The memory which is used to perform merge sort is high, which is n. N is nothing but the number of elements in the list to be sorted. Why it is so high? Coming to bubble sort, insertion, selection, quick, they do not use much memory. Their memory complexity will be literally 0 or 1, right? But here it is n, because merge sort uses a temporary array of the same size which is equal to the number of elements of the list which we need to sort. So that temporary array which we are going to maintain till the end of sorting is the main crux of the story, and it is the one which raises the space complexity of merge sort. If you look into the slide, you can see that how how the function is going to work. The merge function is going to work. It is going to divide the whole list into two halves. Right? And it is going to further divide them into minute pieces, breaking them into half recursively, such that each and every element becomes a piece in itself, an independent one. I'll tell you and explain you the same with merge sort algorithm. There will basically 3 steps in it. Very simple one. You are going to break the list into pieces such that you get one element, only one element in the list, and once you divide the list recursively into halves and you reach the place where you cannot further divide it into, then merge the list, match the elements which are the root. I'll explain you with this a small example. I'm not going to tell you the whole sorting algorithm, which I'm going to explain you using a pseudocode as well as a few animations, right? So how it is going to divide, that you need to think of first. So 5, 1, 3, 6, 4, 9. For example, these are the elements which you have. So first of all, it is going to divide it into two halves. The first one will be 5, 1, 3, and the second list will be 6, 4, 9. So these lists are further divided into two halves. One is 5, the other is 1 and 3. So you are going to get 5, 1 and 3. Here you are going to divide it into 6, 4 and 9. So 6, 4, 9. 5 is a single element which you cannot further divide. So bring it down, then followed by 1 and 3. They can be further divided into 1, 3. 6 cannot be divided, so bring it down. That is it to the next step. 4 and 9 can be further divided. So 4 and 9. So you, if you look into the structure, you have divided the whole list into pieces. You have broken them into pieces such that the leaf, if you construct a tree structure for this one, taking the given list as the root node, right? If you take this as the root node, you are going to get two children in the first breaking. Okay, 6 and 9, I'm going to break it into two children, right? Further, this is divided into two children, 1, 3, 6, 4 and 9. It is further divided into 5, 1, 3, 6 will be carried forwarded. So, can you see a tree-like structure, a top-down structure, where you can see that all the leaf nodes are single data elements. So, how we are going to perform the sorting technique? We are going to merge the elements by sorting the things in an intermediate state, right? So, let's have a look at the basic pseudocode of this thing. Okay, the pseudocode of merge sort is basically divided into two halves, right? So have a look at this one. Here in the merge sort, the basic function merge sort, variable A as array, that is A is an array over here which I am going to send. If the size is 1, that is the number of elements in the array are 1, there is nothing to sort order, so you send it back. Return the list as it is. If it is not the case, break it into two pieces. Have a look at variable L1 and L2. You have broken that into two halves in such a way that so 0 to index values 0 to n by 2 will be placed in L1 and n by 2 plus 1 index number to n in the L2 list. Two lists, right? So as I have shown you previously, so one large list will be broken into two halves, right? Recursively you have to do it. So for example, this is A, then its left will be L1 and right will be L2. Got my point, right? Again, L1 is going to call itself. You are going to repeat the same process. Have a look at this statement. We are going to recursively call itself to break this into L1 into a further L1 and L2 pieces, right? And L2 is also recursively been called L1 and L2, right? So in this way, a structure will be formed. Once this is formed, once you break it, so you are going to return the resultant lists to merge function. Merge is the actual function which is going to sort and place these elements, unsorted elements, into a sorted way. Let's have a look at the procedure of the same. Merge. Have a look at this one. Merge is going to take an array A and another array B. That is two lists. Have a look at this. This is nothing but your function call, where you are sending two lists as parameters. Now have a look at this function definition. Here it is taking two lists, that is two arrays as arguments, right? So actual arguments and formal arguments, right? So what you have to do now, you have to recursively check whether you have elements in A and B or not. If one of the lists end, then the sorting is done, right? Unless you reach the end of either one of the lists A or B, or both might end at a time if they are broken into halves, equal halves, right? So compare the elements. This is what we have to do. Compare the elements and sort them. What if the element pointed by the index value in A is greater than B, right? Then place the element in B into the resultant list, which is C, right? So if the element present in A is lesser than B, then place the element of A in C. You have to do only one thing. Compare the elements which are present in list A and B. The one which is smaller will be sent to the final list, which is C. Please remember, C is the final list which is going to hold the final list. There is a point you need to remember, guys. What if A and B are not of same length? What if they are not of same length? That means, say, list A has come to an end, and in B still you have elements. What you are supposed to do? Then have a look at this one. When guys have a look at this statement, when this condition is going to break, while condition, it is going to break if either the elements in the A end or B end or both end. Any case, you are concatenating that with AND operator. What AND says, if at least one condition is false, the whole condition, the cumulative condition itself is false, right? So the cases where either A or B is left with few elements, what you have to do then? Have a look at this pseudocode. The first case 1. Okay, let me take the while loop, the initial while loop as case 1, so that this becomes case 2. A case where the list B has become empty and A is still having elements. When A is still having elements, just remove the elements from A and place it in C. Copy them. Leftover elements in A, copy them into C. Or you may also get a case, that is the third case, where the elements in A are over, but B is still having few elements. In that case, copy the elements in B to the final list C. Right? So by the end of this function, you are going to return C, which is the final list which holds the sorted one. Remember, guys, A is the input list of size n and C is the final list of size n. Get my point? So C is a temporary one which I have taken to sort the elements and which got filled with the final resultant of same size n. That's why the space complexity of merge sort is very, very high. It is equal to the size of the number of elements you want to sort. I hope you understood this pseudocode. Let me explain you the same logic with the small animation. Okay, so have a look at this piece, guys. Watch carefully. The first one. First and foremost point is, array is an unsorted list. 2, 4, 6, 8, 9, and so on. ARR is an array is an unsorted list, right? So I'm going to take 2 pointers. Before going to take 2 pointers, I have to identify the start index and end index to get the initial and final values of the index. Okay, so we cannot say that always the start will be 0. If you break that into 2 halves, on the right hand side, the start index will change, right? So I have specifically taken start and end to be 2 variables which are going to hold the lowest index and highest index respectively. Okay, now have a look at this one. I've taken 3 pointers or 3 variables which are going to hold the index values I, K, and J. Okay, so I is going to, first of all, I'm going to calculate start plus end by 2, which is assigned to M. to get the mid position, which is equal to, here in this case, 0 plus 8 by 2, which is equal to 4. So have a look at this one. M is pointing to 4. What is M? M is nothing but a variable which points to the middle element. Okay. Once you calculate the middle element and your M is pointing to the middle element, we can easily get the positions of I and J. Because, have a look at this one. On the left hand side of M, you have a list, and on the right side of M, you have a list. Two lists are there, right? So in the previous, as per the pseudocode, if you want to call them as L1 and L2, I don't mind, right? Left hand side list will be L1 and the right hand side list will be L2 respectively. Okay, so these two are two lists. In these two lists, the first element will be pointed by I, left one L1, and in the list L2, the first element will be pointed by J. M acts as the boundary between them, the two lists, boundary between the two lists. Now, how to sort it? The primary condition. If the element pointed by I is less than or equal to the element pointed by J. Okay, what is the element pointed by I? It is 2. Less than or equal to element pointed by J is 3. Is the condition true? No. Because, the condition is true. 2 is less than or equal to 3. Condition satisfied. If the condition gets satisfied, very simple thing that you have to do is copy the element in array pointed by I into temporary. Have a look at this one. Even this is an array. Okay. Into that array. Yes. The size of temp is equal to the size of array. AR. Okay. So, and it is regulated by the variable K. K is initially pointing to the first index, which is 0. So, as the condition got satisfied, you have to just copy the content pointed by I to K, right? So, that means you have sorted and placed the element 2 into the temporary list. So, once the job of I is done, increment the pointer I, and coming to K, as the first index value of K is filled, increment K, right? We are not going to touch J because the element pointed by J lost the condition, right? The element pointed by I won the condition. So, right? So, as the pointers are moved, have a look at this picture now. I is pointing to 4 and J is pointing to 3. The second condition will be, have a look at this one. The element pointed by I, which is 4, is greater than the element pointed by J, which is 3. Condition satisfied. Who won the bet? Which list is having a lower element? The element pointed by I or J? The element pointed by J. So, copy the element pointed by J into the kth location of or kth index of array temp. Okay, so once I'm going to do this, have a look at this one. 3 got inserted into the list, right? As 3 got inserted into the list, that means 3 is being used. You used it. Once you have used it, increment the pointer J. Okay, as per this one. And in the current location which was pointed by K, you have filled with some content, Jth content. So, increment K. Increment K. Right? Increment K. This is what I'm going to do. Have a look at this picture. So the pointer pointed by I is as it is, whereas j got incremented. Now have a look at this one. The element pointed by I is 4, whereas j is 5. Less than or equal to condition satisfies, right? So which element is lesser? The element pointed by I is lesser, right? So bring that element into my temporary list. So I brought 4 directly to my temporary, right? I have copied it. Once I have copied it, I have used it. I have used it in sorting. So I'm going to increment the value of I. Coming to the pointer k, as you have filled the current position with 4, I need to think of the next blank. So I'm going to increment k. So I have incremented k and incremented I. So the new element pointed by I is 6, pointed by j is 5, right? So let's have a look at the changed list. Yes. Now I is pointing to 6, j is pointing to 5. Then what is the relation between the elements which are pointed by I and j respectively? Let's have a look. The element pointed by I is 6, whereas the element pointed by j is 5. The element pointed by j is lesser. As I wish to get a list in ascending order, so I'll be concentrating on the element which is having a lesser value, right? So copy 5 into temporary. That is the element pointed by j into temporary. Okay, so once you copy that, right? So the element pointed by 5 is being used. As the element pointed by j is used, I have to increment j. Right? I incremented j. And on the vacant position of k, I have filled it with the element of j. So I have to think of the next slot. I'm going to increment k. So as you see, k and j are incremented. Got it? So then as I lost the bit and I is having an element which is higher one compared to j, so its position is not going to change. So further the list will change as, so now I is pointing to as it is 6, whereas j is pointing to 7. So coming to the elements pointed by I, 6 and 7, the relation between them is less than or equal to. Right? So less than or equal to. The element pointed by I is lesser. So copy that into temporary. So I copied that into temporary. Right? So the vacant I to blank one it was pointing to, there you have filled it with the lower element 6. Okay, so as 6 is used, there is no point in thinking about I. I'm going to simply increment it. I'm going to increment it. Now I is pointing to 8 now. As now it is pointing to 8 now, my k, even it is supposed to fill its next location, so it is also incremented. I'm going to increment I as well as k, both. Right? So the resultant list will look like this. Right? So I is pointing to 8 and j is pointing to 7. Both are reaching to the end of the list, my dears. Okay. So what is the relation between them? 8, 7. So the element pointed by j is lesser when compared to the element pointed by I, right? So what to do now? So just copy the element pointed by j into the temporary right? And I've copied that. As the element pointed by j is used, I'm going to increment j. I'm going to increment j, right? So as the variable pointed by I was not having any work, right? So it lost the bit as it was carrying an element which is higher when compared to the element pointed by j. So its position is not going to change. Coming to k, I have filled it with a blank, that's blank value with 7. I'm going to increment it to the next vacant place so that it can be filled with a proper element, right? So this is the result of the next, right? So I is pointing to 8 and j is pointing to 10. What kind of relation these two share? 8 is less than 10. That is, the element pointed by I is less than the element pointed by j. So I won the bet. So as I won the bet, I'm going to copy the content of I into my final list, right? So I'm going to copy the content 8 into the temporary list. So as I have copied and used the content 8, I'm going to increment I. Okay, and as the vacant place in K is been filled, I have to increment K to get the next slot where I can fill it with some data. Right? You can see that I have reached a place where I'm reached the boundaries. I is at its boundary and even J is at its boundary. Right? So have a look at this one. So have to compare these two now. So I and j both are at final steps, right? So I is going to I is holding the value 9, whereas j is holding the value 10, and they share a less than relation between them. That is, I is holding a value which is lesser when compared to the element pointed by j. So the value pointed by I is going to come to the final list, right? So as 9 is being used and I. So I'm going to increment I to have a look at the next element. Even I have to increment K so that I can fill the next blank space. If at all, if it is there, to fill the next space. There is a point that you have to observe here, guys. You can see that I crossed mid. What was the index value of M? M was holding 4, right? But I crossed M. That the boundary, have a look at our previous talk. The list, say L1, is navigated by an I variable whose range is from 0 to 4. Coming to list L2, it is going to run using the variable j whose boundary is from 5 to 7, right? So what is the index value which I is holding now, which is 5? Did it cross its boundary or not? Its boundary is from 0 to 4 index value only. It crossed its boundary. What does it mean? It means that the list of the elements present in L1 are over. That means are already been utilized in final sorting. But where J is pointing from its boundary 5 to 8, and it is pointing to the 8th element, that is 8th index valued element. It didn't cross it. Only when it's going to cross the value, it will tell you that the list is over. All the elements in that list are being used. Have a look at this one. Here the bid by I variable I want that to bid because it is holding a lesser value when compared to j, which is 9. So I've used it, but still the element pointed by j is not yet used. So kindly recollect the pseudocode which we were thinking of, which we have learned just now. Okay, whatever the case may be, either one of the lists may get empty or both may get empty at a time. We have to copy the content of the remaining elements in the leftover elements in any list into the final list, that is the resultant list. Here the resultant list is temporary, right? So the whatever the element that is present in j, pointed by j, that is the second list, will be copied to the temporary list. Have a look at this condition. As I value is greater than mid, that means it tells that I have crossed its boundary. So the loop breaks. The first while loop breaks. As the first while loop breaks, we have to check. As the first loop is end, it got an end. We understand that the first list is over, but we do not know the situation of the second list. May be over or may not be over. So check whether j is less than or equal to end. I hope you understand why I have stored the value of end now, right? So compare. If it is not equal, if this condition, right, the condition satisfies, then copy the content in j into the resultant list, which is temporary, and increment k and j respectively. That means you are going to hop, okay, till the list, the second list L2 ends. So final will be, see, the temporary, only one that is left over in the second list L2 is the element j, which I have copied into my temporary. And you can see that the number of elements which are in array and temporary are same, the number of elements, but still we need to understand it logically. So increment the value of j. So j1, as I have used the element present in j, I'm going to increment it. But what are the boundaries of L2? It runs from 5 to 8. But the j value has reached a value 9, index value some 9, which goes out of boundary. Now even the second list L2 has reached its final state, even it crossed its boundary. So the sorting is done. Okay, so this is the final list. Final sorted merged list, which we get by implementing merge sort technique. Guys, I hope you understood this merge sort technique. Few things you have to keep in your mind, guys. This is a recursive function, first of all, and it relies on divide and conquer. At each and every stage, you are going to break the list into two halves in such a way that you cannot further break them. Okay. Two conditions you have to check. First condition is if the element pointed by I is less than or equal to the element pointed by j. If this condition satisfies, then into the temporary variable, copy the content pointed by I, because I is holding a value which is lesser. Okay, so if the element pointed by I is greater than the element pointed by j, that means the element in the second list is having a higher value when compared to I, right? So into the temporary, that is the final result, copy the element of j. Whatever the case may be, increment k, right? If you have used the element I, increment I. If you have used the element pointed by j, increment j. That's it, right? So this is the while loop. This two sets of conditions are going to sit under the body of while loop, which says that while the the two halves, right? The two halves of A and B, right, are not going to end. Once any one of them ends, so this while loop can break if either left side or the right side list of A come to its end. That is, if I crosses its boundary and J goes out of bound, both are one and the same. If either one of them is satisfied, then we have to simply check while J is less than or equal to end. But if J has not reached its end, then copy the content of J into T and increment T K as well as J. If the contrary part of the same. Second list is over, but the first list is still having elements. If the first list is still having elements, that is a case where while I is it is not crossed its boundary, is less than or equal to mid. It has not crossed its boundary. Then copy the elements of I into the final list, that is the final sorted list T, and increment K as well as I. Got it? So these are the things which you are going to do. Okay. Remember guys, it is a sorting technique which is dependent on divide and conquer. Even though it suffers space complexity, it will be highly useful if you are having huge data. Huge data, it also suffers with the point K. You need to sort a huge set of elements. You have to use a huge set of temporary variable also, temporary list also to sort it and to get the final list, because within the list itself we cannot swap the things and we cannot sort it. That is a drawback with merge sort, which you are going to overcome when you learn quick sort, which you can follow in my next coming videos guys. All the different sorting techniques like bubble sort, insertion sort, selection sort, quick sort, heap sort, all the sorting techniques have been explained, and a demo of the same using animations is presented in my future videos. You can see few are already been posted, few are in the upcoming stage, you can see. But remember this one, it is an in place sorting technique. Please remember, in place means you are not going to disturb the list, the actual list. Have a look at the primary list which was there in our hands, ARR. The content in it which was unsorted in the first stage itself, in the initial stage itself, by the end also it is unsorted only. In place, it is not going to get disturbed, but you are going to get the result in another list which is stem, which I generally call it as the resultant list. Okay. And the usage of merge sort is to sort the elements in sort the elements. It can be homogeneous or heterogeneous also. So here I have taken homogeneous data to explain you. Like numericals I have taken, I have not even taken fractions. You can implement similar searching techniques for characters also. What if you want to sort, say, the list C, X, A, D, P, B. You can sort it based upon ASCII values. It is going to sort. Okay, guys. So you can implement the same in Python, C, any programming language you want to adopt, you can do it. And I have given a demonstration of merge sorting in Python, right? Please go through my videos. You can see that I have given a full-fledged working code of merge sort in Python, right? I hope this video is useful. Please do follow the remaining sorting techniques, which are very helpful in data structures. Basically, data structures where data is stored in different ways, like linear data structures, non-linear data structures. So linear money, stacks and queues, non-linear trees and graphs, where we are going to search data. First of all, we are going to store the data, then search, insert, and delete are the basic operations that we perform on the data. In that, sorting also is one of the good operations, or most prominently known operations we generally perform on the collection of data, that is using data structures. So searching and sorting are the basic techniques which we need to learn if you want to perform certain operations on linear and non-linear data structures. Guys, I hope you understood the concept, and this is a finalist, okay? And I hope you understood the concept. Do follow me and follow my videos. Thank you once again. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.